this means that to find the y value, you use the same points, the same values of x at a stationary point to find our y. So you are going to take the first value, substitute it into the original equation to find the first turning point. Take the other value of x, substitute it into the original equation to find again this point, which is the turning point, the second turning point. That's how to find the stationary point. So if we can just go back again, we said we are to find the y-intercept. For y-intercept, we let x to be 0 and then solve for y. After finding the y-intercept, you go to the next step, which is finding the x-intercept. For x-intercept, you let y to be 0, factorize by firstly, remember that if you are to factorize a cubic function, you firstly find the first factor using factor theorem, and then use any method to factorize. But firstly, to find the first factor, you use any value from -6 to +6, that is a factor of 6. Any value that is a factor of 6. That doesn't leave a remainder if you are to divide it by or to 6. So you factorize by firstly finding the first factor using factor theorem, and then factorize completely using any method, and then solve for x. After solving for x, you move to the next step of finding the stationary point. You let the derivative to be 0, factorize and solve for x. After finding those values of x, you go back to the original equation using same values of x to find the y values at the turning point. The last point is a stationary point. A stationary point. A stationary point. A stationary point. Right. Stationary point, divide our graph into 2 equal half. We divide our graph into 2 equal half. It's where our graph changes its concavity. So for stationary point, you find the second derivative. Our first derivative, it's given by 3ax squared plus 2bx plus c. So to find our our point of inflection, you need to find the second derivative from that function. So you derive for the second time. Find the second derivative. This will be 6ax plus 2b. Right after finding the second derivative, again, you let the second derivative to be 0. Let the second derivative to be 0. We are going to let our second derivative to be 0. And then solve for x. So our second derivative is 6ax plus 2b. You let it to be 0. So you've got x only now, there is no longer y. So it's a matter of transposing and then solve for x. After finding the value of x, let's see what will be the value of x here. It's 6ax equals negative 2b. We divide here by 6a. Therefore, our x will be equal to negative b over 3a. That's the value of a. Right, after finding the value of a, we need to find y. This is our second derivative. The second derivative is not y. The first derivative is a gradient. So for us to find the value of y, we go back to original, which means you go back to this function, ax cubed plus bx squared plus cx plus d. So that's the equation you are going to use to find the y value using that value. That will give us our point of inflection. Alright, the key thing here is that always after finding the value of x, for you to find the value of y, you go back to original equation. Right? I just want us now look on how to interpret now the graph, because this was curve sketching. Now let's look on how to interpret it now. Right. You've got this graph. And let's say this is the function of h. You must be able to tell if this is an increasing or decreasing function. So since it goes down twice, that means a is negative. Therefore, it's a decreasing function. Right. We are not saying it will have 3 roots. Remember that the roots are the X intercepts. We do not know how many roots it will have up until we have our Cartesian plane. So if you are to, for instance, to draw a horizontal line here, to draw a horizontal line like that, that will mean the horizontal line will cut this graph 3 times. The value of x here is not the same as the value of x there and also at that point. Let's say again, this is point A, point B, point C. So the values of x at each of those points are not the same. They are unequal. Since the horizontal line cut this graph 3 times, that will mean this graph will have 3 unequal roots. 3 unequal roots. Right there, let me indicate the stationary point again. Let's say this is point G and point E. Right. We've got x is to y at d. X at d, let's put d also here. Up there, the coordinates, x at e is to y at e. The point has to correspond, right? So, when you look below point E, remember this line can go up to infinity, and also that can go down there up to infinity. So, below this point here, just below that point, again, still the graph or the horizontal line cuts the graph 3 times. Everywhere here, just below point E, and also above point D, above point D, above point D, just above that point. The graph, the horizontal line will cut this graph at 3 points, which means here, this graph the horizontal line cut this graph 3 times. If the value of y is above the value of y at point D. And again, we are going to have 3 roots, 3 values of x below point E. So we are going to have 3 values of x where y at E is below that value there. Therefore, we are going to have 3 unequal roots. We are going to have 3 unequal roots below point E. Let's look at the value of y below point E. So if you move from point E going down, that means it's where y is less than y at E. We are going to have 3 unequal roots where y is less than y at E. And again, when you look here, we're no longer going down to find 3 roots. We are going up from that point. So, for 3 unequal roots again, it's either you move from point E downward or you move from point D upward. Therefore, it's where y is greater than y at E. That's where you are going to find 3 unequal roots. Right. Let me draw the graph again. Okay, we said this graph can go up to infinity. Right. In this case now, let's say this is point A, point B. So the coordinates here, x at A is to y at A. Here, it's x at B is to y at B. Right. If you are to put a horizontal line here, you are to put a horizontal line just below the turning point. That's where it will cut our graph. Also here, just above that point, if you are to put a horizontal line there, remember a horizontal line represents the x-axis. The horizontal line represents the x-axis. So here we've got only one root. We've got only one root. If you are to draw a horizontal line just below this turning point, which is B. Above that point again, which is point A, we are going to have one root. Our horizontal line will cut this function. Let's say this is the function of k. It will cut the function of k once. If we are to draw a horizontal line just above point A. Therefore, we've got one root. write one root. Where do we find one root? Just above point A. Just above point A. Therefore, what is the value of y above point A? y above. That means greater than y at A. Just above. Y must be greater than y at A for us to find one root. And then again, this is a root, not roots, because we are talking about one root. Again, we've got one root here, just below point B, we've got only one root. Below, that is less. Below, it's less. Which means the value of y must be less than y at B for us to find one root. Right. Now, let's say we have this type of a function. Where our horizontal line passes through the turning point. Hey, what type of a turning point is this? Right. Right. When you look here, we've got that turning point in that there. Let's say this is point A, B, C. X is to X at C. Y is to Y at B. Right. So we've got that root and also that root there. If you have a horizontal line that passes through the turning point, you are going to have equal roots here. You are going to have equal roots. So at that point, the roots are equal. So if the roots are equal, which means we are going to use one value of x there, which means now the horizontal line will cut this graph at this point and also at that point. So when you look, we've got only two now, only two values of x that are not the same. Two unequal roots. There are two unequal roots. Where do we have two unequal roots? Two unequal roots. Right? It's where our, oh, this is why it's not x. It's where our y at that point. It's where our y at that point. Remember that now the horizontal line passes through that point, which means y must be there. Y must be there. It's where y is equal to y at point C. Y must be there for you to have two unequal roots. Y must be there. Two unequal roots. Y must be equal to y at B. For us to have two unequal roots, y must be equal to y at that point, y must be equal to y point C. Right. Right, let's draw our Cartesian plane. Another point, our y-intercept, let's say this is point D, and also we have the stationary point. Let's say this is point E, another stationary point here. Let's say this is point F. Right. So remember that we said when we are talking about the gradient, let's say this is the function of F. Right, the gradient is positive. We are going upward, so the gradient is positive. The gradient is positive. It's positive at any of those points. Since we are going up, the gradient is positive. But at this point, the gradient is 0. At the stationary point, the gradient is 0. In terms of y is our function of f. Y below the x-axis, y is negative. It's negative. Our y is negative. But at this point, our y is equal to 0. Above the x-axis, our y changed to be positive. Our y changed to be positive. Our y is positive. Above the x-axis. When you are to go down there, the gradient at the stationary point is 0. But if you are going down now, the gradient is negative. The gradient is negative. We have a negative gradient. Negative gradient. Negative gradient. At this point again, at this point, the gradient is equal to 0 at this point. In terms of y again, remember we are above the x-axis. So let's try to have another diagram so that we are going to make this clear. So here we are above the x-axis. So our y is positive. Our y is positive. Our y is positive. Our y is represented by f, right? And then here at this point, at that point, our y is equal to 0. Below the x-axis, y changed to be negative. Changed to be negative. Right. Y is negative. negative, at this point y, which is our f, it's 0, right? But above the x-axis, our y is now positive. Our y is positive. So why am I indicating all these signs? It's because you might find a question that will ask you to multiply the gradient, to multiply the value of the gradient times the value of y. Not equal. We multiply here. You can find the question that will ask you to find the values of x that will give you a positive answer. A positive answer if you are multiplying the gradient times y. You are multiplying the gradient times y. So it's simple. If you know this sketch, negative times positive, it's negative, which means this is out. But here, the gradient is positive, also y is positive, just above this point. So if you are to tell about the values of x squared, you are to multiply the gradient times y and get a positive answer. You will say, we are talking about the x value there. It's where x, when you move downward, you are going to have a negative answer. So x, if you are to move to that direction, x is less than the value of x at this point. But if you are going up, x keep on increasing. X is increasing, so that means just above point A, x is greater than this value at this point. So it's where x at A, x must be greater than x at A. Let me put it like that. It's where x is greater than x at A. You will find a positive answer if you are multiplying the gradient times your y. You will get a positive answer. So look at the values of of x. It starts above point A to be positive. In terms of the value of x is increasing, keep on increasing. So for this to have a positive answer, if you are to multiply, x must be greater than the value of x at that point. Remember that the gradient up there is equal to 0. So if you are multiplying 0 times f at x, the answer will be 0, which means the turning point is not included. So you are going to multiply the gradient up to this point, up to this point. This point is not included. So you can't include this point, and also you can't pass here. You either move from point A, but you do not pass this point. You rather go back. You go back. Or you move from this point upward. So x must be greater than this value here. If you are to go back, that means x must be less than the value of x at that point. So that is point E. So we've got two values now of x. It's where x greater than x at A, but x must be less than x at point E. So for you to write the answer for that, you are going to say, since we are talking about this portion only, it's this portion only, that part. So you only have one x value there. X must be less than x at E. But it has to be greater than x at A. X must be less than x at E, but greater than x at A. Let's check again. Is there any part in our graph where we are going to find the positive answer? I can't see this graph now. Right?